problem on de Moivre's theorem. Here we have to prove that -1 plus I root 3 whole upon 2 raised to n plus -1 minus I root 3 whole upon 2 whole raised to n is equal to -1 if there is one condition, that is if the value of n equal to 3k plus or minus 1 and its value is equal to 2 if n equal to 3k. So guys, it means here we have two conditions, and for two conditions we have two different results. So we have to prove that it is equal to -1 for n equal to 3k plus or minus 1, and we have to prove that it is equal to 2 for n equal to 3k. So let's start. Now the question is how to get that answer. So guys, if you can see that power n which is written outside the bracket, and in the bracket there is a complex number, so it clearly shows that we have to use the de Moivre's theorem, because de Moivre's theorem says that using de Moivre's theorem you can find out the power of a complex number, and n is a power and we have a complex number with that power. So to get or to apply the de Moivre's theorem, there is one more condition, that your number must be in polar form. So here the given number is in Cartesian form. So let's convert that number into the polar form, and once we convert it into polar form, then we can apply the de Moivre's theorem very easily. So guys, let's start. So what I'll do here is I will assume that this given number is z. So z equal to -1 plus I root 3 upon 2 whole raised to n plus -1 minus I root 3 whole upon 2 whole raised to n. Now let's find out z first, and every time I'll prove that z is equal to -1 and z equal to 2. So now I'll denote this number, or I'll call this number by z. So let's start. So first of all, I'll convert this number into the polar form. Okay, so for -1 by 2 plus I root 3 by 2. So for this complex number, r is given by square root of x square plus y square. So here I'll say it is square root of square of this, that is 1 by 4, plus square of this, that is 3 by 4, and we will get answer as 1, because 4 by 4 is 1 and root of 1 is 1. Similarly, theta is given by the formula tan inverse of y upon x. So y is root 3 by 2 and x is -1 by 2. So we can cancel this 2 and 2, and we will get it as tan inverse of negative root 3. Now guys, if you see this number, then x is negative, y is positive, and if we plot it on coordinate system, then that number will come in second quadrant. So it means my theta should come between 90 to 180, since this number lies in second quadrant. So let's start. So tan inverse of negative root 3, how do we solve it? So I've shown you method in the previous videos, so let's repeat that method once again. So accordingly, here that will become minus tan inverse of root 3 and minus, as it is, tan inverse of root 3 is pi by 3, and since this negative pi by 3 will lie in fourth quadrant and we want angle to be in the second quadrant, we will add pi in that, and therefore we will get answer as 2 pi by 3. So guys, we got theta as 2 pi by 3. So now we got r and theta for first complex number. What about the second number? So it's again very easy, because the second number is the complex conjugate of the first number. So can you see here, this imaginary part is positive, but in the second number it is negative, and the real part is same. So it means we have the complex conjugate of the first number. So for the complex conjugate, we know that r and theta will remain same, and only the sign of imaginary part will change. So I will use the same r and theta for second complex number. So let's start. So here I would say therefore the value of z equal to. So let's write down the number in polar form. So for first number we got r as 1, so no need to write r because since it is 1, and theta is pi by 3, so I will say the complex number is it is 2 pi by 3, so it will be cos 2 pi by 3 plus I sin 2 pi by 3 whole raised to n. Similarly, for the complex conjugate, which was the second number, we will get plus the same number, that is cos 2 pi by 3, and here we'll take negative. So negative I sin 2 pi by 3 whole raised to n. Now let's apply de Moivre's theorem. So here I would respect Mr. de Moivre and I will write down his name. So here I'll say therefore by de Moivre's theorem. So de Moivre is basically the god of this theorem. So every time whenever we will use his theorem, we have to mention the name of the god, that is the de Moivre's theorem. So let's go ahead. So here by de Moivre's theorem we'll take that n inside and we will get cos of 2 pi n by 3 plus I sin 2 pi n by 3. Similarly here we'll get now we have to add these two numbers, and you can easily figure out that sign is here positive and here negative, so we can cancel this sign term, and by doing that we will get 2 times cos of 2 pi n by 3. So guys, this is the value of z, but we didn't get the answer which is required. So what was the answer which is required? So we want answer as negative 1 and 2. So let's start with the condition. So first condition is given if n is 3k plus or minus 1. So let's start here. So here I'll say when the value of n equal to 3k plus minus 1. So let's see what happens. So that time z will be 2 times cos of 2 pi and the value of n is 3k plus or minus 1 upon 3. So this is 2 times. Now cos of, let's multiply inside in the bracket by 2 pi by 3. So 2 pi by 3 into 3k, we will get 2 pi k plus or minus 2 pi by 3 into 1 is 2 pi by 3. Now guys, what is the answer of this? So there are many methods to get the value. One of the method is cos of 2 pi plus theta is cos theta. So here I can directly say that cos of this 2 pi k plus 2 pi by 3 is cos theta, because guys 2 pi k and k is integer which is given in question. So if k is integer, we know integers are like 1, 2, 3, 4 or negative 1, negative 2, negative 3 and so on. So if it is 1, 2, 3, 4, then this will be 2 pi, 4 pi, 6 pi, 8 pi. So 4 pi plus theta of cos, that is cos of 4 pi plus theta is also cos theta. Cos of 6 pi plus theta is also cos theta. So we get cos theta every time. Therefore the answer will be cos theta. So here I'll say it is 2 times cos of 2 pi by 3. So 2 as it is, cos of 2 pi by 3, that is cos of 120 which is minus half, and if we cancel it we will get negative 1. So guys, can you see that I proved the first result, that is minus 1. Now let's prove the second result which says the answer is 2 if n is 3k. So let's go back. Here I'll say therefore when n is equal to 3k. So now let's see what happens. So z will become 2 cos of 2 pi, the value of n is 3k upon 3. So here we can cancel 3 and 3. So we will get 2 times cos of 2 pi k, and where k is integer. So if k is integer, its value will be 1 to 3, and here we will get cos 2 pi, cos 4 pi, cos 6 pi, and so on. And we know that cos of any even pi is equal to 1. So that is 2 into 1, which is equal to 2. So guys, here I've used one property, that is cos of any even pi. So you can remember this formula, that cos of even pi is 1 and cos of odd pi is equal to -1. Similarly, whenever you get sign of even or odd, that is we say any pi, then answer is always 0. So you should remember these three formulae, because that will help you out in solving the trigonometric questions. So guys, here we have proved that second result is equal to 2, which was required. So by using De Moivre's theorem, I've proved both the results, and I'm sure you like this video very much. And if you want to learn more videos on complex number and the other concept of engineering mathematics, then keep watching our channel and the website. And on the website you will get all videos in sequence, which you can access anytime from anywhere. Thank you guys.